Hello and welcome to Minute Micro Macro. We're starting our AP series and looking at the 2024 paper. So I'm going to read it. Soja Farm is a typical profit-maximizing firm that produces and sells soybeans in a constant cost, perfectly competitive market that is in long-run equilibrium. The market equilibrium price of soybeans is $14 per bushel. Draw correctly labeled side-by-side graphs for the soybean market and the soybean soja farm, and show each of the following: market equilibrium, price and quantity; soja farms, profit maximizing price and quantity; soja farms, average total cost curve constant with long run equilibrium labeled average total cost. So they've given us lots of hints in the question. It's a typical profit maximizing firm and perfectly competitive market that is in long run equilibrium. Three really key points. So step one, they just want a market equilibrium. That is basic first unit economics. If you get stuck, got all of unit one on the YouTube channel. We need to use a ruler to draw our axes. We know we've got price on the y-axis and quantity on the x-axis. We're going to label our axes, price and quantity. We also need supply and demand. We know that supply goes to the sky and demand is drawn down. And if you've watched any of my videos, you know that I like to color code. So demand down in red, supply to the sky in blue. This has formed an equilibrium. Our equilibrium is here where the two lines intersect. We draw a line downwards and that we read off of the x-axis for the quantity. We're going to label that QM because that's what the examiner asked us for. And we read our price off of the y-axis, and they told us that's going to be labeled at $14. Part II. Soja Farm's profit maximizing price and quantity. So we've drawn our market here. Now we need the individual firm here. Again, we're going to draw our axes using a ruler. Now, we want to be able to read our price, our cost, and our revenues off of this axis. For this exam board, they're happy with price and cost. And other exam boards sometimes ask for output on this axis. We're happy with quantity for the AP exam board. Now, it's a perfectly competitive firm. It means they're price takers. So we're going to draw a horizontal average revenue that reads from the market. They take the market's price. So perhaps make it really clear, keep tracking our price across. We're going to show average revenue. And let's show average revenue in red. Now, because it's a price taker, our marginal revenue is going to lay on top of that. And I like to show marginal revenue as orange. Now, we know that in equilibrium, they're in a long run equilibrium. So they're going to be making zero supernormal profit. And this is what we're going to label my average total cost, always in green. Our marginal cost curve always cuts through the minimum point of average total cost. And we can then read our profit maximizing quantity for our firm off of this diagram. We know that the profit maximizing quantity is where marginal cost is equal to marginal revenue. So the first thing I do is I read this blue and this orange line, find the point they meet. From there, I go down, and this is the quantity the firm are going to produce. They've asked us to label that as QF. Now, they want to know the price that the firm is going to charge. I'm going to read up from my quantity until I hit my average revenue. I always draw my average revenue in red, so I'm going to go up till I hit the red line, and then I read across onto my price cost axis. So here, I'm going to label that PF. So it's the firm will charge. Have I done everything? Let's check. The market equilibrium price and quantity. Yes. Soja Farm's profit maximizing price and quantity. Yes. And Soja Farm's average total cost consistent with the long run equilibrium labeled average total cost. Yes. ATC is here. So we've done part A. Part B. If Soja Farm is the only firm in the market that chooses to increase its price of soybeans to $15 per bushel, will Soja Farm's total revenue increase by $1, remain the same, or decrease to $0? So this is Soja Farm, and we know that the entire market is at an equilibrium at $14. Another thing we know about perfectly competitive firms is that they sell homogeneous goods They are all the exact same. We know that all the consumers and producers in the market have perfect knowledge. And so if they put their price up by $1, all the consumers of soybeans would switch from Soja Farm to another producer. And that means that Soja Farm's total revenue, is that what they asked for? Yep, total revenue would fall to zero because they would have no consumers left. No one would buy a good in a perfectly competitive market above the market price. So you just need to write Soja Farm's total revenue would fall to zero. All the consumers would switch to buying from producers selling at market price. That would get the marks. Part C. The question says, soybeans are used as an input in the production of tofu. Tofu now becomes more popular food option among consumers. On your graph in part A, show that the short-run effect of the increase in popularity on tofu on each of the following. The new market equilibrium price and quantity of soybeans labeled P2 and Q2 respectively, and Soja Farm's new profit maximizing quantity labeled Q star. Well, it told us that tofu has become more popular, it's more fashionable maybe, it's a trend. We know that that means that demand will shift outwards. It's going to shift to the right. If you're not sure about that, go back to Unit 1. If the demand for soybeans increases, that means if the demand for tofu is increased and we need soybeans to make tofu, the demand for soybeans is going to increase. So we're seeing an increase in demand. Instead of drawing a whole new graph, I'm going to draw on top of this one. We're seeing an increase in demand. We're seeing it shift to the right. So that was my first demand. They've asked me to label it. I'm going to call it D1. I'm going to show a shift to D2. I'm going to show that the price has increased, and they want me to label that as P2. And the quantity has also increased. They want me to label that as Q2. Now, we know the firm is a profit maximizing firm, and they're in a perfectly competitive market. And so they're going to take this new equilibrium price. So we can track across, and the new average revenue, a marginal revenue, will now be higher. We're going to call this AR2 and marginal revenue 2. Now, because marginal revenue has changed and the profit maximizing point is based on where marginal cost is equal to marginal revenue, we need to see where the blue and the orange lines intersect again, which is now here. Because that has changed, I've got a new profit maximizing quantity, and we're going to label this Q star. Firms in perfectly competitive markets can make a profit in the short run. So this is all we need to do for part C. Moving on to D. Well, given the increase in popularity of tofu in part C, what will happen to the total number of firms in the soybean market in the long run? Explain. Well, write this out, give me some space to write. If they're making a profit in the short run, that would be a signal to the market, and it'd be a signal to the new firms to join the market. This is particularly easy because we're in a perfectly competitive market and there are no barriers to entry. So if a profit is made, people will join that market to try and get some profit for themselves. If we're seeing an increase in new firms, what's going to happen to supply? There's going to be an increase in supply. So a profit signal to the market, new firms will join the market. There would be an increase in supply. And we've answered that question. Yes. E now. Part E. I'm going to wipe this clean so we've got space to write about it. I need to remember to cut that. It took far too long. Okay. Part E. Suppose a 25% increase in the market price of quinoa causes a 5% decrease in the quantity demand of quinoa and a 10% increase in the quantity demanded for tofu. That's quite a few numbers. Let's get those down. So we saw the price of quinoa go up by 25%. It also told us that the demand for quinoa is going to fall by 5%. Nothing surprising there. We've got an inverse relationship. When price increases, demand decreases. It's a downward sloping line. And then it also told us that the demand for tofu is going to increase by 10%. I like to get my numbers down so it's easier to comprehend. We are seeing, for the first part of the question, An increase in price of quinoa rises by 25%, a decrease in quinoa falls by 5%. We want to know about the elasticity. Is the demand for quinoa elastic, inelastic, or unelastic? Explain using numbers. We can almost immediately see that the percentage change in quantity demand is less than proportional to the change in price. And so if we've got percentage change in quantity demand being less than the percentage change in price, we can say that demand is, let's tweak that slightly, perfect. We can say the change in demand is less than proportional than the change in price. Therefore, the PED for quinoa is going to be inelastic. And by having the phrase less than proportional and inelastic, you get the marks of the question. But let's just make sure we have revised and have bagged all the marks. Let's actually calculate PED. To calculate PED, we do the percentage change in quantity demanded divided by the percentage change in price. Percentage change in quantity demand was a fall of 5%, so let's say that's -5, divided by positive 25. Well, I can tell you that's, if I times both of those by 4, I'm going to have it out of 100, which gives me a percent. So that's going to be -20 out of 100. So that's 20 divided by 100, which is going to give me -0.2. With PED, we take the absolute value, and so we don't actually have to worry about its negative value. We can just say 0.2. Then we've definitely got the marks of that question. Part II, calculate the cross-price elasticity of demand between quinoa and tofu. So XED, change colors, so it's clear this is part B. XED measures the responsiveness of the demand of one good to a change of price of another good. And we can calculate XED by saying the percentage change in the quantity demanded of, in this case, tofu, divided by the percentage change of price, quinoa. Well, the percentage change in quantity demand of tofu was 10%, was positive. The percentage change in price of quinoa was 25%, also positive. I can do the same trick by times them both by 4, and I'm going to have 40 out of 100. Notice they're both positive, so my answer is positive 0.4. Now, with XED, we do not find the absolute value. We care if it's positive or negative. As my answer is positive, that means that we know they are substitutes. The question doesn't actually ask me to state whether it's substitutes or not, but it helps me with a sense check. Does it make sense that quinoa and tofu are substitute goods? You either have one or the other? Potentially. And so that is part E done. On to question 2. I'm going to read it first. Good X is produced and sold in a perfectly competitive market. The provided graph shows the market for good X, and I've got that printed here. The first thing I'm going to do is just try and understand this graph. There's a lot of lines that cross over, and I feel like they're there to distract me. So, first thing I do is I think to myself, supply goes to the sky, and private cost is very similar, arguably the same as supply, and private benefit is associated with consumption, therefore demand. So I like to draw my supply and demand graph over the top. Now that I've got that down, we just think about what's going on with the lines that are overlapping and not overlapping. We can see that we've got marginal social cost equaling marginal private cost. So there is no externality, positive or negative, associated with the production of this good. And then we've got marginal social benefit greater than marginal private benefit. So this is associated with the consumption. And if the social benefit is greater than the private benefit, there must be some sort of positive externality associated with the consumption of this good. Now we go back to the question. A, identify the market equilibrium price and quantity. Well, now that I've got my coloured lines overlapping that, it's quite clear to see that my supply demand graph overlap at this equilibrium. And so for part A, my market price will be $15 and my market quantity will be 300. I like to annotate that with QFM because it reminds me of the quantity in the free market. So part A identify the market price and quantity, you just need to write $15 and 300 for quantity. Calculate the dead weight loss at the market equilibrium. So we can see that there's some sort of externality, and that means that there's some sort of dead weight loss. At the free market quantity, there is a social benefit that is greater than my private benefit. The social benefit is equal to $25, but the private benefit is equal to $15. If I continued to increase the quantity that is being consumed in the market, this amount of net benefit has been left on the table. This amount of net benefit has been left on the table all the way until we reach a point where my social cost is equal to my social benefit. These two lines create an equilibrium here, and so my socially optimal quantity is at 400 units. So they've asked me to calculate the dead weight loss at the market equilibrium. Well, the dead weight loss is all of this net benefit that's been left on the table, and that's a triangle. Base of my triangle is this gap here. I can see very clearly that's a gap of 25 minus 15 is 10. The height of my triangle, if I turn my head on its side, I can see it is a gap of 100. And to find the area of triangle, it's base times height divided by 2. 10 times 100 is 1,000, divided by 2. And part B, my dead weight loss is equal to the value of $500. Part C, suppose the government wants to eliminate this dead weight loss. Which of the following will achieve the government's objective? A per unit tax on consumers or a per unit subsidy to consumers? We know to increase demand so that our marginal private benefit equals our marginal private cost at the socially optimal quantity, I need to shift my demand curve to the right. So go back to unit 1 and think, what shifts demand to the right? Well, we need to increase consumption. So what we can do is we can give a subsidy to the consumers. They'll reduce their personal private cost of purchasing the good. The phrase we like to use is it internalizes the external benefit. So I'm going to write that out. We want a per unit subsidy to internalize the external benefits. This will increase the incentive to buy the good and increase consumption to the socially optimal level of 400 units. So per unit subsidy to internalize the external benefits to increase the incentive to buy the good and to increase the consumption to the socially optimal level of 400 units. What is the dollar value of the per unit tax or per unit subsidy identified? Well, we want to shift this out. We're thinking about it in terms of what vertical shift to show the increase in money will cause it to overlap with this line. Well, I want to shift it up by 10 units, so I'm going to have to increase it by $10. $10. Okay, part D. Suppose instead the government imposes a price ceiling of $10. Will the price ceiling achieve the socially optimal quantity of good X? Explain. Well, price ceiling means you can't go above it. So if the government came in and said, here is our price ceiling, that would mean that we would not be able to reach an equilibrium. We would have a disequilibrium. The amount that people would want to buy would be at 400, because that's where our price and our demand curve intersect. The price that people would be willing and able to supply would be 200. And so, no, that would not work. So, will this achieve the socially optimal quantity? No. The producers would only supply 200 units. Question 3. And I've printed the whole question out so I can look and read it nice and easily. Okay, so you can see we have a payoff matrix. Nice Ride and Field Cruisers are the only two producers of vehicles. Nice Ride is deciding whether to improve its safety or comfort. Okay, There's a lot of information. I don't like it when the tables are laid out like this, so I'm going to color code everything. Nice ride is deciding whether to improve safety or comfort. So nice ride are deciding between safety and comfort. Nice ride are on the left, so the first number in each box is associated with nice ride. Okay. Field cruiser is deciding whether to improve reliability or power. So field cruiser, looking at reliability or power. And so the numbers associated with them are the second numbers. Now that it's color coded, it's a little bit more clear and intuitive. The payoff matrix shows the payoff for each combination of strategies. The first entry in each cell shows nice ride's profit. Right, so these numbers recognize the profits. And the second entry shows field cruiser's profits. Each firm independently and simultaneously chooses its strategy. Assume the two firms know all the information in the matrix and do not cooperate. What is field cruiser's most profitable strategy if nice rider chooses to improve safety? So if nice rider chooses to improve safety, we can completely ignore comfort. So we're just going to block it out. Now, what is field cruiser's most profitable strategy? So field cruiser can either make 28 million or 35 million. So it's quite clear that their most profitable strategy is to improve power. And the explanation is because 35 million is greater than 28 million. Okay, part B. Does nice ride have a dominant strategy? Explain using the numbers for the payoff. So nice ride are in blue. Do they have a dominant strategy? So let's have a look. If field cruiser went with reliability, nice rider could either choose to focus on safety and make 10 million in profit, or comfort and make 30 million in profit. Here, it would be in nice ride's interest to prioritize comfort. Let's see what happens. If field cruiser were prioritizing power, can ignore them for now, what would nice rider do? They could either make 32 million prioritizing safety, or they could make 25 million prioritizing comfort. So here, they would make more profit if they prioritize safety. And so because the preferable strategy is different depending on what field cruiser will do, they do not have a dominant strategy. Do they have a dominant strategy? No. You write out what I just explained. You'd use the information that 30 is greater than 10 million dollars, whereas 32 million is greater than 25 million. And so they do not have a dominant strategy. Is nice ride choosing to improve safety and field cruiser choosing to improve power a Nash equilibrium? Okay, nice ride choosing to improve safety. So they're choosing one of these, and field cruiser choosing to improve power. Field cruiser power. So with this top right box, is this a Nash equilibrium? So we have to check with ourselves. Is there a reason for either party to move from this box? So now we're in this box, nice ride could choose to move to comfort. No, they won't be doing that. They're not going to choose 25 million in profit over 32 million profit. Okay, so they don't have a reason to leave this box. Does field cruiser want to move from producing power over to reliability? They could make 35, or they could move to make 28. No, they won't be moving. So yes, this is a Nash equilibrium. Yes, neither benefit from changing strategy. You'd explain that using the numbers that I just verbally explained. Part D. Suppose nice rides and field cruiser decide to merge to maximize combined profits and choose to keep producing both nice ride and field cruiser vehicles. Assume the value in the payoff matrix do not change. What would the new firm's total profit be? Okay, let's get the whiteboard pens out. So if they decided to merge, what would happen? So I'm going to draw out my own grid following. So I'll set up my grid. If they merged, 10 plus 28 is $38 million. 32 plus 35, we've got $67 million. Comfort and reliability, we've got 30 million plus 40 million, we've got $70 million. And then comfort and power, 25 million plus 20 million, we've got $45 million. Okay, so if they're a merged company, they're going to go with a strategy that makes them the most profit. And so field cruisers are going to produce reliable cars. Nice Ride are going to focus on comfort, and they're going to make 70 million in profit. The final question. Suppose instead that a change in fuel prices reduces the profitability of choosing to improve power by $10 million for field cruiser. Identify each firm's profit at the Nash equilibrium. So if fuel prices reduce profitability of power, so I'm going to reduce these numbers by 10 million. I'm going to have my pen. So we're not going to be thinking 35 million. We're going to be thinking $25 million. We're not going to be thinking 20 million here. We're going to be thinking 10 million here. We're looking for a Nash equilibrium. We're going to be operating at the point where they're going to be making the most profit, where there's no reason to move from. And so I think if I'm in comfort and reliability, there's no reason to move from that block. And let's just double check that. Okay. If I'm in this square, is it likely that Nice Ride is going to move to safety? No. If I'm in this square, is it likely that Field Cruiser is going to move to power? No. So identify each firm's profit at the Nash equilibrium. The profit is going to be 30 million and 40 million.